Now, please welcome Sebastian.
Thank you. Hello. Mhm. Cool. So, hi. I'm excited to be here today with you guys. My name is Sebastian. I am from Colombia. I live in Bogota, which is the capital of Colombia. And you can find me as Sebasoga in Twitter and GitHub. Um, so I do what a lot of people call like back end development. And I work for a startup called Ride. It's based in New York, although I work remotely. And what we're doing is we're like trying to reinvent the way people commute. So so far during this conference, we've heard like really interesting talks, and we've heard about Trailblazer, Bolt, and Lotus. Oh well, almost heard about Lotus. Um, and right now I'm gonna talk about like I mean like all of those frameworks or ideas uh, try to solve try to solve like really common problems when we are writing applications at the application level. Right now I'm gonna talk about microservices, which is kind of the same thing but more on a like system design level. Um, so I call the talk like microservices a bittersweet symphony because although I really like microservices, I am aware that they're not perfect. They're not like a silver bullet and have a lot of downsides that we're going to talk about. So before we get into what microservices are, I want to tell you like a story. So this is a story about like the first job I had. It was at a stadium. So it was like a easy job. It was simple. So I was just like selling hot dogs on game days, and it turned out that I was good at it. So my manager decided that other than just selling hot dogs, he wanted me to also sell like foam fingers. So I said, okay, like that makes sense. I'll do it. That's fine. And then he thought like, okay, you're good at it. You're really fast. So you should also like announce during games when a player is substituted by other. That was really weird. It was a bad idea, but I had no choice. So I said, okay. Uh, again, like unsurprisingly, my manager lost an employee, and that employee was in charge of like mowing the lawn. So he asked me to do it like before each game, and I gladly say okay because it was like extra money for me. So it was not a problem. But what happened is that I started with one responsibility, just like selling hot dogs. And now I had four. It was getting a bit intense. After that, like my manager asked me to like help with accommodation. He wanted me to help accommodate people, and I was like, "What? Are you crazy? Like, when am I gonna do this? Like, I have to sell hot dogs, like sell foam fingers. I have to mow the lawn before before the game." But I had no choice again. So it was either that or I had to like leave the job. Uh, so I accepted. By the way, I'm really sorry about like using a One Direction ticket. It was like the the best image I could find on Google. Uh, so like unsurprisingly, what happened next is that actually One Direction showed up, and I had to accommodate them. So that was like, I don't know, that was too much for me. I just decided that I was exhausted, I was bored, and I decided to quit. Like I couldn't properly handle all of those responsibilities. Uh, okay, so that's the end of the story. So you probably, by now you probably realized, I hope I don't disappoint you, but by now you probably realize that this is just made up story, right? But I'm trying to make a point with this. I'll get to it. So uh, I want to ask you guys a question. Which of you have a system that you would like to break down into like smaller things, whatever that thing is? Raise your hand. Okay, cool. I think it's more than half. So, like most of the people that raise their hands are probably working with monolithic applications. And the ones who didn't raise their hand, uh, if they're not working with like monolithic applications right now, they probably will at some point or had in the past. So pay attention anyway. uh, so what's like a monolithic application? It's it's just I mean, a monolithic application is like the simplest way to build I don't know, an application or a system. It's the way we most of the times we start just like that. And the problem with monolithic applications is that after a while they turn into a big ball of mud, and that's like a really common situation, unfortunately. Uh, and that and what makes a monolithic application a big ball of mud is basically like poor object-oriented design. Um, so with each new feature that's added, like what happens is that you add more code that's not well designed, that's poorly designed, and you start like going slower and slower every time as time passes and the application grows. Uh, so the problem with that type of applications is that they end up being like really coupled. So you start like going fast, you're really happy, everything's good, and at some point you hit like a roadblock where you find out that everything's like so messed up that it's probably like easier to rewrite or to quit or something like that because people didn't really care about like what they were doing and the design of the application they were working on. Um, so there's where microservices come in. And let's start by talking about what are microservices. So does anyone, I mean, I'm sure a lot of you have an idea of what it is. Who wants to say a definition? Almost, that's close. Services by Microsoft. Okay. I know you can do better, guys. Who has another idea of what microservices are? Small services. Yeah, that you're right. Really good. You won a medal. You can like claim it at the end of the talk. So yeah, that's basically it. I mean, uh, to sum it up, that's like a really good quote. In a few words, microservices are just like a set of applications working together, and those applications can be like independently deployed. So the like one really common question with microservices is like, are microservices just like service-oriented architecture? Isn't just like the same thing? And like the answer actually is yes. The thing is that like although service-oriented architecture as an idea started out like really well, talking about like separation of concerns and replaceability and all that stuff, it like deviated from that initial like idea, and it started talking about like discussing about like how services should communicate, like what protocols should they use, like what middleware should you use to build like a service-oriented architecture. So it ended up like, in my opinion, losing the focus that it initially had, which was like a really good idea. So that's where like microservices came in back again, and because for me like so I ended up being like everything and nothing at the same time. It talked about a lot of things, but also it wasn't like, I don't know, like really opinionated to call it somehow, which is exactly what the microservices like architecture style tries to propose. So basically, we could say that microservices are just like a subset of service-oriented architecture. You could say that it's the same thing as what a Scrum is to Agile. It's just like a way of doing stuff. Things. So microservices are not like something that new. Most of the ideas presented are not new. It's not like a hipster thing that everyone's talking about right now because it's like what every programmer wants to do. It's something that like some companies have actually been doing for 10 years, but there wasn't like a specific name for it. And actually, since we're talking about the name is a bit confusing because I think that like the name microservices is a bit unfortunate. Uh, like the 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 most important thing is that I mean, the, sorry, let me rephrase that. Like the worst thing about the name is that it focuses too much on the size of the services, and that's not like the most important thing about it. And we'll see why. So, how big does a service has to be considered a microservice? There's like a lot of discussions about it. Some people uh, say that there has, I mean, a service has to have less than I don't know 100 lines of code, 1,000 lines of code. I don't really like that concept of like measuring in lines of code because that changes a lot from language to language. Like, should you count like third-party libraries or frameworks if you're using them or not? That's not a good standard or like metric to decide if a service is microservice or not. Some people just say that microservices are microservice if it's built by like a small team. It can be built by a small team, and there's like a famous quote I think by the founder of Amazon. I don't know. It comes from Amazon when they say where they say they have like 2 pizza size team. So if you can feed like your team with 2 like regular pizzas, it's a good enough team to build a microservice. If it's bigger, it's not a microservice. That's kind of weird too. So basically, what I like to say about microservices is that like if you ask yourself, if I had the chance, if I had the time, if I had no restriction, would I want to extract something from this service or would I leave it as it is right now? If the answer is that you will leave it as it is, then it's a microservice. It's small enough for it to be considered a microservice. If not, if you still would like to remove something from it, it's probably not a microservice yet. Especially if you want to remove more than one thing, that's probably like a monolithic application. Okay, so like what can you do? How to do that? Like how can you achieve building microservices out of like monolithic applications? So this is going to sound a bit weird, but you should start with a monolith always. Like I wouldn't recommend someone to start from scratch building a system with based on microservices. It's probably not a good. I mean, when you're starting from scratch, it's probably not clear enough yet what the microservices should be. You should like let the system tell you what they should be or what they should do. So that's where you should start. Then you should get the design right. So this is really important because if you want to like grow from a monolithic application to a bunch of microservices, you need to have a good design. And if you're not able to achieve a good design, even of a monolithic application, you're not going to achieve it using microservices. And it's probably going to make it even worse. And you're going to like lose all the benefits of having microservices. So it's not worth it. So this is like a really good quote I found on Twitter, I think. And it says like, if you can build a structured monolith, like why would you want to build microservices? That makes no sense. So the most important problem to fix that the microservices try to fix, in my opinion, and that's not specific to microservices. Like it's probably with any type of architecture. It's like what I call the boundary problem, and that means like what's the best way to decide what goes where. So even if you're building a monolithic application, this is a problem you have to fix all the time. When you're like adding new logic, new business logic, when you're implementing new features, implementing new requirements, it's always really important to know like when some responsibility starts and some responsibility ends, and how to communicate between like those boundaries and how to really well define them and like not break encapsulation. And encapsulation doesn't only apply like to objects; it applies to modules or services. As we'll see later. So that's like the really that's like the most important problem you start to have solving since the beginning. So we have like solid principles, which are like object design level principles that help you like write uh, yeah, software or objects that are like reusable and are basically not coupled, so they can be like changed easily. And also we have the package cohesion principles. Those are only like three principles. Those are really useful to know how to like create modules basically. So how to group objects. How do you know which objects should be together, should be part of like a component if in a software application or system, and those are really useful and are not as known as the solid principles. You should check them out. Um, so, so like something I really like to tell people when they're like starting to build microservices is that they shouldn't be afraid of doing it. And as the quote says, as perfect is the enemy of great, and it's that some people are too afraid of like start to like to break apart the monolith and start building microservices because they want to have like the perfect architecture. They want to have like everything perfectly designed, like what each microservice should contain and how they should communicate among them. So it's really hard to like nail it down from the start. You should just start, do whatever you think is the best at that given moment, and start iterating from them. Um, so one like the last recommendation I would give someone starting to build microservices out of a monolith app is to start by like the specification. So this might sound obvious, but I've seen it's not that obvious. And it's like the first thing you should write down is the specification of how your service is going to work. So like a contract. So let's say you're building a service that's going to expose a RESTful API. So the first thing you should write down is like, okay, I'm going to have this endpoint. I'm going to receive like a payload or arguments like this, and I'm going to receive this, return this specific payload formatted like this. And that sounds like kind of obvious and basic, but if you convert this specification into some sort of executable, like documentation, this will save you a lot of headaches, and I've experienced it. For example, for building RESTful applications at Ride, the company I work for, we use something called API. I don't know if you're familiar with it. And that's pretty useful because of like three main things I would say. The first thing is that once you write down that specification, any system depending on the microservice you're building doesn't need you to implement it. It can use like that specification as a stub of your service, so you won't get people blocked because you're not done yet. They'll be able to start working based on that stuff because that's what I end up building. The second thing is that you can use that specification or that like executable contract as your integration test, if you want to call it like that, because you'll know that you're done, or that your microservice is done, is doing what it's supposed to, once you run that like executable contract and it passes. If you have like a code base that make that test pass, you're basically done. And you know that everyone that has been building around your microservice, even using like the stuff, will be able to change the stuff or the mock for your newly developed microservice, and everything should work. And so that's the second thing. And the third thing is that it allows you to like throw away the microservice you just wrote because you just found that I don't know, there's the best way to implement it. You want to try it out in a different language because it has better performance, or you want to like re-implement it because you want to use a different type of database or whatever. You can just throw it away, and you know that you have that executable contract there that you can run again against the new service you write in whatever technology it is. And as long as it passes that test, you're golden. You can continue without worrying about it, which is one of the like main advantages of microservices. Okay, so yesterday Nicolas was complaining about like no one showing kittings on the presentation, so I decided I would use like the whole quota for the speakers on this slide. Um, and now let's talk about like what not to do. So it's easy to say like what to do because it mostly common sense and a little bit of experience, but what not to do is not so obvious. And I'm gonna like talk from some experience, personal experience, and also like from stuff I've seen people doing that I wouldn't recommend. So let's talk about the key things. So the first one is like don't share active record models. That's a really bad idea. In any way, like don't create a gem that you use in different services to like connect to the same database and to share the model so that you don't have to write them twice. You shouldn't even have that problem. You shouldn't be like sharing databases between microservices. That's like defeating the whole purpose of it. It's like breaking encapsulation. If we were talking about object-oriented design, it's like if you were calling private methods on another object. Like, so what's the point of like having private methods if you're going to call them anyway? The same thing with databases. Don't use the same database for different microservices. If you're doing that, it's because you probably you designed your architecture or the microservices boundaries are wrong. You have to check what's going on and probably like find a boundary problem there that you need to fix. If by any reason you end up like sharing a database, what I recommend is like at least make one of the microservices in charge of writing. Only one microservice should write to the database and the rest can read. That's still bad, but it's not as bad as like everyone writing to the same database. And if that's not possible, like at least do it at a like table level. So just allow one microservice to write to a specific table and the rest of them to read. But that's just like taking it too far. That's probably still a really bad idea. But if you're doing that, at least I think that would make it a little bit worse. The next thing is avoid Conway's law. This is a law that basically says that any organization that like designs a system will build a system that reflects like the way they communicate among each other. So there's a like really useful graph here. For example, if in your organization you have like teams of like front-end developers, back-end developers, and database administrators, it's really common for organizations like that to end up like creating an architecture that reflects that. So okay, let's have an app that does all the like front-end stuff. Then let's have like a lot of short procedures that do database-related stuff, and that's always a bad idea because you should, the architecture you come up with should reflect like the business logic of the problem you're trying to solve, not the internal structure of your company. Another thing is that like don't overload small teams with like all the operational costs this type of architecture comes with, and that's a really important point that a lot of people don't realize. Like this is not an architecture that I would recommend for a really small team because it requires like a lot of DevOps. It requires like a lot of automation and operation that you have to like be doing day after day after day. And if you have a small team, like developers will burn out. It requires a lot of work, a lot of discipline, and I wouldn't recommend it for like a really small team. Okay, the last thing I think I would recommend not to do is like to violate the golden rule of microservices. And the golden rule of microservices says that you need to be able to make a change to a service and deploy that's like those changes in that service without changing anything else. So if you end up with an architecture that if you're deploying a microservice, sorry, that has some changes, you need to also like deploy at the same time another microservice because if not, like the system will break. That means that you're doing it wrong. And basically, yeah, you're like losing like the most important benefits of having microservices. And this can happen like I mean, it's more common than you will think. Uh, even if even if you're using as like separate databases, even if you're trying like to isolate, no, like encapsulate all your behavior via like message passing in any form, it's not uncommon that systems are so coupled that you have to deploy them like simultaneously because if not, the system, like the big system, will break. And that's something you should always keep in mind. You should keep them as like isolated as possible so that you can do this and not in like any other microservice, no other microservice, sorry, needs to be changed. Uh, so yeah, this is basically what I was saying. Like the key property of a component is the notion that it's independent and it can be replaceable at any moment. So basically, uh, what what this talks about is that, for example, you have like a sound system, and a sound system you have I don't know, like you have speakers and you have like I don't know, like a CD player or whatever. You should be able to like replace your CD player without having to change your speakers. They should like be able to work together, and every component should be replaceable by another, and everything should still work. So that's basically like the idea I'm trying to explain here, and the idea actually behind like microservices. So now that we see what to do, what not to do, like let's talk a little bit about when to do it, like when it is a good idea to use microservices. So uh, the first thing that is important is that like your team has to be capable of doing some basic stuff to be able to to successfully implement like a microservice architecture. So one of those things is like rapid provisioning, which means like that you're able to in any given moment like provision a server so that you can deploy a new service. That needs to be like almost automatic. If you're not able to do that, it's probably not a good idea to move towards microservices yet. Also, like you need to be able to do basic monitoring, and this is really important. Like way more important than with a monolithic application. When if it goes down, it's like really obvious for everyone because it's just like only one application, so everyone will notice. But when you have a lot of microservices, and I mean, the higher the number, the more important monitoring is because you need to know if something goes down, and you need to fix it as soon as possible, and you also need to have a plan to manage that sort of thing. But we'll talk about that a little bit later. And the other thing is like rapid application deployment. That's really important. You need to be able to deploy a new service that you just upgraded at any given moment, and which is really related to what I just explained. Like you need to really make sure that they're not coupled. Okay, so another moment when you should go towards a microservice architecture is when like an app crosses like the human cognitive mass threshold. I explained what that is. That's basically like a concept that even Phoenix came with, and it means that like we all can contain a certain amount of information in our brains at a given moment. So if an app is so big that we can't like fully understand it and like have it in our heads at any given moment, it's already too big enough to be like just one application. You should break it into smaller ones. So another reason, I mean, another moment when you probably need to move towards a microservice architecture is like when you need to scale a specific part of your system, because normally when we have like a monolithic application that's having performance problems, it's not because like the whole application needs to be, I don't know, needs to be scaled, or has scaling issues. It's probably just like a small part, a really specific part. So one thing you can do moving towards microservice architecture is like to extract that like part that needs to be scaled into a microservice and scale it on its own and leave the rest of the application alone because it probably don't need any change. So that's another reason to go towards this architecture. And another good reason is when you like already have services, they're not really like microservices. They don't comply with this like characterization we just saw about what a microservice is. But still, you have like duplicate, duplicated logic among them. So you have like stuff that's being done on more than one of those. So it's probably a good idea to just extract that commonality between the systems or services, sorry, and just create a small service that can be reused by all of the other services that already have that business logic. Uh, okay, so now let's talk a little bit about like why you should use this type of architecture. So the first thing is because like it's basically like this, like turning what a big thing in a bunch of small things, and that's always cool. And also because services are easy to replace. So if a service is not like uh, being, I mean like meeting your performance needs, you can easily replace it with something else, something that is more performant that meets your needs. So that's one good reason. Another good reason is that you can like independently deploy them, so you don't need to like deploy the whole monolithic app to make a small change. And the problem with this is what I've seen is when you have like a monolithic app that's like hard to deploy or like risky to deploy, you tend to not deploy it or to, I mean, to wait as much as you can to do it. So you end up like accumulating like a big chunk of changes. So that ends up making like the deployment even riskier. So at the end, like it's a really bad idea. So when you have small services that you can like deploy at any time, independently of the rest of the system, you know it won't break anything. You'll just do it like I mean at any given moment you want to do it. So that's always good. Also because you can like do something that they call like technology heterogeneity, which basically means like you can use the right tool for the job. And this can get crazy because like some companies just think that you should allow anyone to build any microservice using any technology they want if they think it's the best fit. And that makes sense, but it can also like get out of hand. So some companies decide that you can only like use something that's inside of this tool set that they just like arbitrarily decide what includes. And for example, at Ride, what we do is like when we need to build a new service, we just like open something we call like a request for comments. So we basically like do a proposal, write it down, send it to everyone in the company, and everyone has like an amount of time to comment about it. And at the end, we need to like get to an agreement of how we're going to implement it, and then that how is not only like about design, but also like about like the technology stack we're going to use. Okay, so what are the downsides of this type of architecture? So the most complicated thing I think I've seen is inter-service communication. You know, there are a lot of options. Like we have synchronous and asynchronous communication. Each one of them have like some benefits and some drawbacks. We have different types of, I mean, like different ways of communicating with protocols. So we have like HTTP, and we can have like RESTful APIs. We can do RPC. We can do like message passing via like a message broker. So like finding the right tools to use there can take a while, especially because you need to be prepared to manage failure, which is one of the next points I'm gonna touch here. So. So you should expect you should expect failure. Uh, Things are gonna fail. That's. I mean, we all know that happens. So you need to expect microservice to go down. You need to expect like a message broker to stop working. So you need to have a plan to downgrade functionality and do it in a way that's graceful and the whole system doesn't shut down. And that takes like a lot of planning, a lot of work. So that's why I mention it as a downside, because it's something that you don't really have to plan for when you're just like building a monolithic application. Um, and that's basically like what the cap theorem talks about. You can have like two of three, and the three of are like the C is consistency, the A is availability, and the P is partition tolerance. So you can try to have the three of them, but it's always like impossible to achieve them at a 100% level. So it's always important like to have a plan for failure, and be able to manage it. Okay, so another downside is that you have to log, like you have a lot of logs from different microservices, so it can get like complicated to debug something when something goes wrong. It's like a DevOps intensive approach. It's like it's really recommendable that you use like a platform as a service if you're doing microservices. If not, you're gonna have like 10 times of as much work as you were having before. So this is like really important. Like choose one platform as a service. It will help you a lot. Uh, okay, so although like microservices is like a young idea, a lot of companies are like already getting into a big scale of implementing like this architecture. So there must still be like some drawbacks we're not aware of that we'll start like to learn about them as time goes by and more people start using this like this type of architecture. But the ones I mentioned are like the ones that are well known right now and are like the most common. So let's just do a quick recap before we wrap it up. So microservices won't fix your design, like your software design problems. You need to be able to do like to manage to do good design for your software before you move into microservices. Because if you're moving to microservices hoping that it will fix like all your design problems, you're gonna end up disappointed and even in a worse situation than when you were before. Also, like they solve a lot of like common problems, but also bring new problems to the table. So it's not perfect. It's as everything has some good and bad things. It's always about like what you're willing to compromise. Uh, so wrapping it up, at the application level, we tend to like write small things, small objects, because we think they're more manageable and easier to understand. Uh, at the system level, basically, it's recommendable to do the same. Like the smaller the microservices, like the easier they are to replace, to deploy independently, and like it gives you a lot of more capability to handle complexity in the system. So basically, at the application level and system level, it's always recommendable to try to write the smallest thing possible. Uh, and I think we've seen like on other talks on the application level why that is a good idea. So I want to bring out this quote by Michael Feathers, which I think it's like really appropriate for this talk. And it's that he thinks like there's like a law of conservation of complexity in software. So even if you choose a specific architecture, it doesn't mean that you are like getting rid of complexity. What you're probably doing is that you're moving it somewhere else. And he thinks that microservices, like the smaller the units of your code or system are, it means that you're moving the complexity to the way they communicate. And from my experience with microservices, I think that's really true, and that's something you should be aware of. So I I would recommend that you use like microservices if they help you manage the complexity of your system better, because there's always going to be complexity. If you think that this approach will help you manage it in a better way, go for it. So the last thing is that it's if you're building a system that's solving a problem that's not trivial, you'll end up having you'll end up at some point uh, recognizing that it's better to move to this type of architecture because it helps you manage the complexity I was just talking about a little bit better and it makes your life a little bit easier. That's it. Thank you.
Thank you very much. Anybody questions?
So you said you shouldn't share the database between the microservices. Can you tell exactly what are the problems with that?
Yes. So the problem is that there are like problems at all levels. So one, for example, like if you have like database constraints, for example, that a field can't be nil, can be null. Like maybe one of the microservices don't have the information to put there. So it will, if someone on another microservices like add that restriction, the other microservice will start to blow up. Some other thing is that, for example, you have different validations at the model level, and they're contradicting each other at some point, or they're overriding each other. So there's like a bunch of problems that can happen, and it's basically because of that. You're like breaking encapsulation. You're allowing them to share something they shouldn't be sharing.
What is your preferred way of inter-service communication? Should I send requests or events between services?
That's a really good question, and the answer is tricky because it depends. It depends on what you need to do. Like when you say request, I guess you're saying like synchronous like request, you like a browser to a web app. Yeah. Okay, so for example, like if you have I don't know, a mobile app or a web app, you always need to like respond to a request synchronously. But what I recommend from my experience is like to make as much of the stuff you can asynchronous, because it allows you to manage failure way better. But you can't do it always, as the case I'm just telling you about. So I don't know if that answers your question, but that's kind of like what I try to do.
Yeah, thanks.
Any more questions?
So how do you deal with async programming in Ruby, or what's your architecture between as far as communication between services is concerned? Because do you use some message queuing or?
Yes, so we have a couple ways of communicating. Like the most common, like we don't only use Ruby, we have like a lot of languages on our stack, but regardless of the language, we use a message broker, which in this case is we use RabbitMQ. It's the one we use the most. So we basically just like put messages or payloads or whatever you want to put there in whatever format you want to put it. You can even put bytecode there if you want to. And then like there's a producer and a consumer, and that's really good because if like one of them goes down, like the messages are not lost, and you can just like put the application up again, and everything will continue working without as if nothing had happened.
Okay, I have a question regarding the sharing of the code. Because for me, one of the advantages of service-oriented architecture is that I can assign different groups of programmer to different services, which is useful when you want to protect the technology you are working on, because this way they don't share knowledge about the whole product. And I wanted to ask you about some advices how to share the code, because if I have different repository for each of the services and they share some code, there comes a small problem, how to share it efficiently. I duplicate the code usually.
Okay, so I think you made two questions. So I'll start with the first one. The first one was like, how do you manage people sharing code? Because sometimes you want to protect some part of the application.
Yes.
But that, well, to be honest, I haven't been in that situation. I mean, like, where I've worked before, like, you can always like access any part of the system. There's no like restrictions to it, and that's really good normally because although you might be part of a team that's maintaining one or two or more microservices, it's always good to know how the rest of it works, especially because, I mean, sometimes you might be able to fix other microservices bugs or help them with something you need, for example. But in that case, I don't know. Like, to be honest, I don't know how you can protect for like I don't know, like one of your services for not being known about. I mean, for not being known by everyone. I think that's actually not something specific to this architecture. It's something that you should have to like manage some other way, which I don't know. I don't know how you.
Yes, one thing which came to my mind was Git submodules and adding special deployment keys for it. So
yeah, but that's just like a matter of like where do you give people what do you give people access to, but like as far as sharing, I mean, as far as like sharing code goes, it doesn't. I mean, if like using microservices even helps you achieve that easier because like you can have like a separate repository that you only want a couple of people to have access to or be able to deploy. So I think, I mean, I'm not sure if that's what you're asking because I'm not sure if I understood the question, but
I was interested how to share some code between those separate repositories.
okay, so what I would recommend is just like create a new microservice. That's the best way to. I mean, don't share code. Share the behaviors. Like share the result of what the code does. Instead of like creating a library that you pass around some services, like it's better to just create a service that does what you need for you and everyone can reuse. That's what I would recommend.
Thank you.
I got a question. So, do you have any pro tips or share some thoughts on how you emulate synchronous transactions, like business procedures that need to go step by step in an environment where basically everything is asynchronous because it's all flying around in events?
Yeah, that's a really good question. That was one of like the hardest things for us to figure out. I don't know if someone already solved it and that's like a really good way to do it. What we did is basically like wrote scripts that did stuff for us. Like basically if we needed an event to be triggered so that something was generated and we started communicating one service with another, and that started like a lot of process. I mean, another process because we needed to test the whole thing. That's how we did it. It's like the best way we found so far. It's not like I mean, I don't love it. I actually like kind of hate it because it's boring. It's not something you can repeat easily. But so far, it's what we've been doing. If someone has another suggestion, I will be happy to hear it.
Okay, one more question.
Hi. You said that you're using RabbitMQ, but doesn't it create a single point of failure? Because if it goes down, you know, the whole idea of microservices is just screwed for you because you don't have a way to communicate.
Yes, that's a really good question. That's something really common. The thing is, like, you can, as with any other thing, you can have like a replicated as instance of RabbitMQ running. So if that goes down, like you still have another one to use. That's what we've been doing so far. I mean, we've not run into a situation where both goes down at the same time. That would be really problematic, and that would end up being what you're saying, like a single point of failure for the system or for a big part of it, probably. But I don't know what are the chances of that happening. I hope it doesn't happen. But yeah, that's a good question.
Okay. So thank you very much.
Thank you.